Hello everybody. These are the video notes on dimensional analysis. Before we start this, I please ask that you take a deep breath. Hold it for a second and let it out slowly. Dimensional analysis can be very stressful for students. You have probably never seen anything like this in your academic life up to this point. But I have talked to science teachers at Pike High School that teach AP classes. They say you need to know how to do this. I've for a long time believed you need to know how to do this, but this is new. You may not get it after this video, but we are going to do several. And you may think that your method of doing it is better than this. I'm telling you, this works. So please take a deep breath. We will get through this, but we are about to try something that is challenging. What we are about to do is something, as I've said, called dimensional analysis. Dimensional analysis. You will maybe find it on YouTube and Google and other places. Some people refer to this as unit fractions. And when we even get to this in chemistry, this way of figuring out things even has a special name, even though it's still the same old dimensional analysis. When we talk about this in chemistry, probably March, April, it even has a funny name. I love saying this. It's called stoichiometry. Well, what we are about to do is we are going to figure out problems. We are going to convert units from one thing to another, but even in that, we will probably be solving some kind of problem. The beauty of this is you can have all sorts of different things going on, and you're solving and figuring it out and knowing that you have a probably correct answer all before you even pick up the calculator. So we're really diving into dimensional analysis here, and there's no better way to dive into dimensional analysis than to do a problem. What our first problem is going to be is how many seconds are in 5 years? And notice I give 5 years 3 significant figures. So we want to know how many seconds are in 5 years of time. Well, with everything and every problem you ever do in your life, sig figs, dimensional analysis included, you got to start with what you know. Well, what do we know? We don't know seconds. That's what we're trying to figure out. We may know some other things that 5 years is equal to. We'll get to those. But the only thing we know is 5.00 years. That's it. We know 5 years. That's it. But we also know what we're trying to figure out. And I'm going to put it down here. We want to know how many seconds this is. Well, we now can start doing unit fractions, which is why it's sometimes called unit fractions. We are going to multiply 5 years times something. But what we're going to multiply it by is a fraction. And the fraction we are about to make has years in the bottom. Why do we want to have years in the bottom? Because ultimately we want to get this to cancel. We want to get rid of these years and turn them into something else. Well, what can we put here? We are going to put two things, and so you don't get confused and not see that this is a fraction. I'm going to put parentheses around it. We're going to turn years into another unit, but do we need to go to decades or centuries? Are we trying to go up in time length? No, we're going down. So we need to use a unit of time that we know how many are equal to a certain amount of years, if not 1 year. Well, what is the next smallest unit of time that you know is equal to a certain number of years? I hope you're saying that you know how many days are in 1 year. Well, how many days are in a year? If you say 365, you're there, you're close. You'll probably even get the right answer when we use sig figs. But if you actually look it up, and because of leap years and other issues, the official number of days in a year is 365.24. Now what we have now done here, we have done something called an equivalence statement. Let me write that. Equivalence statement. What we've done here is we have two things that are equal to each other. If you took the amount of time known as 365.24 days and divided it by the amount of time known as a year, they've canceled each other. They cancel each other. So we have now canceled year and year. And if we took 5 times 365.24 days, our answer would be in days. And we would know how many days is equal to 5 years. Because all we have simply done is taken two things equal to each other. We want to get rid of years, so we put year down here. Years have canceled, and since these two things are equal and we do the math, this is going to be equal to each other. A quick example of this that I wanted to show you is just the simple fact that you can do fractions this way, and you've already done fractions this way. If I asked you to figure out what 2/3, how about I say 2/3? If I said 2/3 times 7/8 times 3/7 times 16/2, also known as 8, if I asked you to solve that, you should be able to solve it very, very quickly. You could take 2, sorry about the pen, you could take 2 times 7 times 3 times 16 and get a number, divide it by 3, divide it by 8, divide it by 7, divide it by 2, you'd get the answer. You could also take your calculator and take 2/3 times 7/8 times 7/3 times 16/2. You could do all that, and you're going to get the answer. But let's save some time. Watch this. 2 cancels 2. 3 cancels 3. 7 cancels 7. We've canceled 3/4 of this equation before we even started. What's left? 16/8. What's the answer? 2. And had I backed up, and now I will, let's back this thing up. I said 16/2 originally, right? Let's replace it with 8. Replace that thing with 8, because that's what it is, 8/1. 3 cancels 3, 7 cancels 7, 8 cancels 8. What's our answer? The only thing left, 2. We're doing the same thing here, but now we've got numbers and units to contend with. So let's continue to solve this problem. We have canceled year and year. Right now, if we did this problem, the answer would be in days. I don't want it in days. I want it in seconds. So now we need to do another unit fraction. We're going to do another unit fraction. I'm just going to draw it. I know I'm going to have a number on the top and the bottom. Even if one of them's a 1, that's what it's going to be. Well, what unit can we put on the bottom to get us closer to seconds? The answer is day. We are trying to get these time units to go smaller to get us to seconds. Do we know a unit smaller than a day that will get us to seconds? Does anybody know how many seconds are in a day? I don't. But do I know a smaller unit? What's smaller than a day? An hour. An hour is smaller than a day. I hope you know the numbers that make these two things equal. How many hours are in one day? 24. Day now cancels day. And now if I did this math, 5 times 3.65.24 times 24, I'm going to figure out how many hours are in 5 years. But I don't want hours. I want seconds. So let's do another unit fraction. And just to show you that we can, I'm going to drop down here. Let's do another unit fraction. Two things equal to each other that will convert from one unit to another. I hope you see that the unit we want to put in the bottom is hour. Why? Because hour's on the top and I don't want hour, I want second. So we got to get rid of it. Get rid of this thing. So put hour on the bottom. You may know how many seconds are in an hour. It's 3,600. If you know that and you want to skip right to second and put 3,600 up here and 1 hour on the bottom, you can be done. But just to show that you don't have to know that, let's put 1 hour here. Is there a smaller unit of time that you know how many are in an hour? I hope you know how many minutes are in an hour. And the answer is 60. Get rid of hour on the bottom here, hour on the top here. This is just one problem going all the way through. I've just moved down to a second line, like a sentence. Right now, if I did this answer, I'd get an answer in minutes. But I don't want an answer in minutes. I want an answer in seconds. So I need to do another unit fraction. Here we go. Unit fraction number 4. I hope you now see what needs to go on the bottom. I don't want an answer in minutes. I want an answer in seconds. I need to get rid of that minute. Put it on the bottom. It will disappear. I guarantee it. Because how do you know a smaller unit of time that you know how many are in a minute? Well, I hope you know how many seconds are in a minute. It's 60. And there's 60 seconds in 1 minute. They're the same thing. These are 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 the same thing. And now minute cancels minute. The only unit I have left is a second, and I haven't even gotten a calculator out yet. Well, now it's time to get a calculator out. And when you do, you multiply every number on the top, you divide every number on the bottom. But look what we got. We got all ones on the bottom. So now, what can we do? We can now get our calculator out. And we are going to take 5, I'll punch it in even though it's just going to be 5, times 365.24 times 24 times 60 times 60 equals. That's the answer I get. But now we got to use sig figs. I will tell you, you don't need to worry about sig figs in any of the conversions. The better the conversion, and use a good conversion table. I gave you this number, and these don't even really have sig figs, because there are sig figs past this 24. It's 24.0 forever, because 1 day and 24 hours are exactly the same. We don't even have to worry about sig figs. And this has been figured, and it's actually longer too, but those are zeros. So sig figs don't matter here, but this is a measured number. I didn't say 5, I said 5.00. This has 3 sig figs in it. So if we're going to write this in with the proper number of sig figs, the answer is 157 million. but we want to write that with 3 sig figs. And if we write that with 3 sig figs, well, here we go. Time for Mr. Ludy to say I was wrong, because we should have rounded up. It's 158 million seconds. Because if we go back to our answer, 1, 2, 3 digits over, that 7 tells us to round up. It is 158 million. So we want to say only the 8 and everything above it or before it is significant. Underline it. The other thing you could do is scientific notation. 1.58 times 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 8 seconds. That's how many seconds are in 5 years. It seems like a lot of work. We spent time doing this problem. And we're going to do one more problem. I had 2 more planned, but I don't want to make the video too long. We will start with something, and we'll do another one probably for bell work, but let's do another one, and let's do it in the way that I would like you to do most problems. So let me cancel here. Here we go. I want to know, why not? I want to know how many yards, I know, English system, I don't like it anyway, but we can still use it. I want to know how many yards are in 16.7 inches. That's what I want to know. That's what I do know. You always start with what you know. 16.7 inches. But all the time signs and all of the parentheses, to me, get in the way. We're going to use something now called the Monorail System. Kind of like the monorail at Disney World or Disneyland. We're going to draw a monorail. Mono means 1. We're going to draw a line. And instead of parentheses to show fractions, we're just going to draw a straight line. We're now doing a monorail. And what I'm going to put here is a fraction. I want to know how many inches are in a yard, or how many yards are in 16.7 inches. I hope you see inches needs to go on the bottom. Why do I know inches needs to go in the bottom? I want to get rid of it. I don't want to know inches anymore. I want to know yards. So we know that's going to be our unit on our answer. How many yards is this? Well, if you know how many inches are in a yard, this is going to be a real short problem. If you know how many inches are in a yard, and it's 36, you're done. You have canceled out the inches before you even grab your calculator. Yard is on the top. You've already set this up. It is ready to go. And if you get your calculator, and take 16.7 and divide it by 36. Your calculator is full of digits, but sig figs tell you what to write. 0.46388888 repeating. Well, I only need that answer to have 3 significant figures. So 4, 6, 3. The 8 tells me to round up. The answer is 0.464. 3 sig figs. Don't worry about sig figs here because they don't really matter. It's not a measurement, it's a conversion. We take our sig figs out of our measurement and put it in our answer. But let's say you didn't know that there were 36 inches in a yard. We still start with what we know. Now, we know inches is going to go on the bottom. Okay, you didn't know 36 inches were in a yard, but I bet you know how many inches are in a foot. And for every 1 foot, There are 12 inches. Inches cancel inches. If I did my answer right now, I'd get feet. And notice 16.7 is a little bit bigger than 12. If I did that math, I'm going to get a little bit more than a foot. Makes sense. But I don't want my answer in feet. I want my answer in yards. I now put feet down here. Do we know how many feet are maybe in a yard? Can we just put yard here now? Yes, we can. And 1 yard is equal to 3 feet. Feet cancels feet. Now we're set up. Our unit is yard, just like it was before. And now we take 16.7 times 1, which is obviously 16.7, divided by 12, divided by 3, and we still get the exact same answer. And using sig figs, it's even more perfect. I know this is a lot. I've already got a problem planned tomorrow for bell work. Let's do one more problem. If you want to stop the video now, I understand. Video's kind of long. If you want to stop right now, stop. We'll do a problem tomorrow, but if you really want just a little bit more, I'm going to go on and do just one more problem. So, one more problem. In order to do this problem, you have to use a conversion table. So I found the conversion table that is in, as I'm recording this, our most current passport. So let me go full screen. This is page R8 of the current year's passport. Now let me zoom in. I am right here because there are a whole bunch of conversions. Move this up. It may be kind of hard to read, but you can see it in person. What is going on here is this is telling you how to go from centimeters to inches. You multiply by 0.39. Okay? Well, for us, we got to know where to put the 0.39. Here's what you do. These are all ones. Every one of these here is a 1. So you want to know 1 centimeter is equal to 0.39 inches. 1 inch is equal to 2.54 centimeters. 1 meter is equal to 3.28 feet. 1 foot is equal to 0.30 meters. And so on and so forth. That's how you read this, and we will need it for what we're about to use. So come back, note this time, and we'll come back and use this later. But for now, here's my question. How many centimeters are in 6.00 miles? We aren't even using the same system. We're starting in English, we're going to SI. So, what do we know? We know what we know. We know 6 miles. Well, first thing, I gotta get this to something smaller, first of all. Centimeters are about the size of your finger, and you know how long a mile is. You drive them in a car. So we gotta go smaller, and we've got to go from English to metric. So, which order you go in doesn't matter. You want to go from miles to kilometers right now, we can do that conversion. Or we can simply make this smaller and then do it to the SI system. I'm going to go from miles, so put mile, I'm putting mile on the bottom. I'm going to go to a smaller English unit because I have this number memorized. 5,280 feet are the same thing as a mile. We got an equivalence statement right here of two things that are equal to each other. Mile cancels mile. If I did the answer right now, it would be in feet. But I'm trying to get to centimeters. So, okay, we're at feet. Now, I don't think we could go to inches. You want to go feet to inches and then do a conversion from inches to centimeters? That works. But here's what I'm going to do. If you look at your conversion table that I just showed you in your passport, it says 1 foot is 0.30 meters. So 1 foot is equal to 0.30 meters. But I have a better conversion table, so if I can find a better conversion table, look it up on the internet, get more digits, you're going to get a better answer. So 0.30, I'm never going to fault you for using it because it's in your passport. But I know from another conversion table that there's a 4 here and an 8 here. Use it if you can, but use your passport because you have it. Feet cancels feet. I've now taken two things that are equal to each other and used them to convert to meters. Alright, hey, we're now in the SI system. And now I hope you can see the next step should be our last. And because meter is on the top, I want to put meter on the bottom so I can cancel it. And do I know how many centimeters are in a meter? You better. It's 100. 100 centimeters and 1 meter are the same thing. I don't even have a calculator out yet. Yet I know that, okay, those two things are equal, and I went mile to feet. These two things are equal because that's how many feet are equal to that many meters. And 100 centimeters is equal to a meter. All my units cancel. The only unit I have left is centimeter. So here we go. Get the calculator out and move it out of the way. 6.00 times 5,280 times 0.3048 times 100. That's what your calculator says. But we can only use 3 significant figures. Looking at 3 significant figures, our answer is going to be about 965, but that's what we're going to round to. The 6 tells us to round up. Our answer is 966,000. 2 ways to write that. We can write 966,000, underline the 6, or 9.66, 1, 2, 3, 4, 5, times 10 to the 5th centimeters. We're using sig figs. We're doing dimensional analysis. If you've made it to the end of the video, take a look at a problem or two on the first worksheet. We will do this for at least a couple of days. If you're confused right now, watch the video again. This is something required, but I need to end this video, so thank you and have a good day or evening or weekend.